Firstly, let progress. Okay then. In AP classes, calculations of weak acids and weak bases has really significant importance. But before that, we have to accomplish calculations with strong acids and bases, and especially calculations for neutralization them. Very firstly, I want to talk about a little bit concept of pH. What is pH, baby? I believe you know it.
It's a scale for testing if it's acid or base.
Yeah, for
Or
25 degrees Celsius. If we have pH less than 7, we may state as the solution is acid.
acid.
And if we have pH higher than 7, we may say that this is base. Okay, this is good. But I want to ask about what the pH is mathematical means, baby. Do you have any idea?
Is it the rate of hydrogen?
No, baby. This is the logarithm of hydrogen ion concentrations, but minus of it.
Mhm.
I believe you know, we have, let's say, we have 10 to minus 4 molar of hydrogen. If we apply the pH rule for that concentration, we have minus log of minus 4.
Mhm.
And it will be, this is easily for, I believe you know little thing about logarithms.
Mhm.
Then we have minus sign for the definition. Then we will end up with plus 4 normal for the scale.
Mhm.
In that way, we may simply say that pH is just removing out the minus power of 10.
Mhm.
Okay? Let's say if we have minus 6 molar of hydrogen ion concentrations, then we have pH of 6. Okay, baby?
Mhm.
This is the case. And also we have same calculation for hydroxide ion concentration. For example, if we say we have pOH of 5, what we are trying to say is simply that the hydroxide ion concentration is something 10 to minus 5.
Mhm.
Okay, but I want to tell you about ionization of water. In that case, okay, water can be ionized partially.
Mhm.
For the starting material, we have liquid form of water, and which has always the concentration of 1.
Mhm.
Then I believe we said so many things about the equilibrium of any solutions. In that way, if we write K water, KW means K water,
Mhm.
the equilibrium for KW is just simply multiplication of concentrations of hydroxide and proton concentrations, baby.
Mhm.
And for again, for the 25 degrees of Celsius, the value of K water is something minus 14. Then we may say that any solution that contains any amount of water should obey this law.
Mhm.
The concentration of hydroxide and hydrogen plus, multiplication of them should be equal to 10 to minus 14.
Mhm.
Then we have another mathematical confirmation for this phenomenon. If we apply the P operation for whole sites, baby, P operation for whole sites. What is P operation? P operation is minus logarithm operation is P operation. Then we will end up with the pH plus pOH will be equal to 14. Do you know this equation, baby?
Mm-mm.
Then we will see what? If the hydroxide ion concentration and hydrogen ion concentration are equal to each other, we have state of neutral, no?
Mhm.
We have the state of neutral. Then let me raise the upper part of the equation. We may get that if concentrations are equal for neutral solutions, they are equal. That means the hydrogen ion concentration times hydrogen ion concentration. Why? Because they are the same. Will be equal to 10 to minus 14. Then we will get this knowledge, I believe you know even from 7th grade.
Mhm.
For the neutral concentration of hydrogen ion concentration and hydroxide concentration will be 10 to minus 7.
Mhm.
That's the why we will state that the POH will be equal to pH, and they both have the value of 7 for neutral solutions.
Mhm.
Okay, baby? This is the same. This is the same thing. And this one also can be derived from this equation.
Mhm.
If they are the same, let's say A for pH,
Mhm.
then POH will also be A. Then two A's are 14, then one A is 7. Okay? This is another way to prove that the neutral solutions have pH of 7, and also the concentration of them will be equal to 10 to minus 7 molar.
Mhm.
Okay, baby?
Okay.
But this one only valid for temperature of which? Do you remember, baby? Which temperature this one is allowed?
25.
Yeah, this is just valid for temperature 25 degrees Celsius. Okay, this is the case. Then we may say that if any solution has a pH value, it should have a POH also. For example, if we have pH of 6, which is a kind of acid, what will be the POH value for the solution, baby?
It's gonna be 8.
Love you, baby. This is the case. This is the case. If we have pH of 6, then we should have POH of 8, which means we have hydrogen ion concentration is 10 to minus 6, and we should have hydroxide ion concentration as 10 to minus 8, which indicates that any solution, babe, any solution, even acid or base, it should contain both hydrogen plus concentration and hydroxide concentration, baby. Even the strongest acid has a limited amount of hydroxide ion. For example, let's say we have pH of 1, which means we have 10 to 1 molar of hydrogen plus concentration. Then we will have POH of 13, no? Then the concentration of hydroxide ion is that much, which is million times million less than that of hydrogen. But we still have hydroxide in this solution, baby.
Okay.
What do you think? If I said we have a pH of 0, what I'm trying to say, what is the concentration of hydrogen ion concentration, baby? What we have?
We have 10 to minus, no, 10 to 0, so it's 0.
No, it's 1, baby, I believe.
Yeah, it's 1, sorry.
It's just the opposite way, because the logarithm of 1 to the 10 base is something 0. Then, which means we have 1 molar of hydrogen ion concentration will yield pH of 0. Do you think if we ever have a pH values less than 0, is it possible, baby?
If there is no hydrogen ion in something, then it's possible.
No. The pH less than 0 means we have in a situation that our solution is extremely acid. Because mathematically, if we have, let's check, we have 10 molar of hydrogen ion concentration, okay? Then we have minus log of 10, which is minus 1. No, because the logarithm of 10, according to 10 base is 1. We have minus for the definition. Then we have the pH of minus 1. Such kind of acidic concentrations may exist. It's quite hard to find them, but 10 molar sulfuric acid is exists, baby. It's possible. Then we may say that we have scale of pH even less than 0 or even more than 14 for real life aqueous solutions. Okay, baby? Because this is okay then. Then the previous knowledge, I believe from the 7th grade or 8th grade, we said that the pH is something between 0 and 14. No, this is not valid. It can be comes from any number n to something m. The m is generally around 14 and n is something generally around 0. But we have minus values for pH. Okay, baby?
Okay.
It is the same. I just want to ask you, if we have pOH of 3, what type of solution is this? Is this an acid or base?
This is acid.
No, baby. I believe you know that if this is pOH of 3, then the pH will be 11. 11 is something base.
Oh, okay.
Okay, then I'm advising you, please always change your given value from pOH to pH. Because normally we are get used to using pH values in our knowledge. If you're given any pOH value, please convert it into pH. For example, we have pOH values of 12. What we have, acid or base?
We have of pH of 2, so it's acid.
Yeah, this is very good. We have pH of 2, then our solution is a good type of acid. Anyway, this is the case. Then let's make calculation. Do you have any calculator around you, or
Yeah, I have.
maybe phone also useful and handy? Okay, baby. I want you to calculate the pH value of this one. We have 2 liters of solution, which contains 4 grams of sodium hydroxide. And I'm asking you, let me erase this one and write down a little bit loudly. What is the pH value of this solution? The solution which contains 4 grams of sodium hydroxide in 2 liters of it. Let's check. We know that sodium hydroxide has molar mass of 40 per mole. No?
Mhm.
Then very firstly, we need to check how many moles of sodium hydroxide dissolved in the solution. In that way, we know that 1 mole of it is something 40 grams. And the
Mhm.
44 grams, what do we have? We have
0.1.
simply 0.1 mole of sodium hydroxide. Okay?
Okay.
Do we have any problem, baby?
No.
Then we just need to turn this one into concentration. The concentration is something mole should be divided by volume of solution. Then we have 4.1 mole of sodium hydroxide dissolved in 2 liters, which will yield us 0.05
0.05.
mole, which is 5 times 10 to minus 2 moles. Then we can easily calculate pOH for this solution because we are facing with such kind of basic solution. Then we have what? We have the minus logarithm of 10 to minus 2.
Mhm.
What the value of this one, baby? I just want to find the logarithm of 5 times 10 to minus 2. Gosh.
Minus 1.3.
Then
It's plus
we have,
1.3.
it's plus 1.3.
3.
This is 1 point plus 3, but this is a pOH value of 1.3. But
Yeah.
I asked what is the pH of this solution. Then it will be what? Yeah, 12.7 is the value of pH for this solution. Okay, this is so good so far, I believe. Did you get the idea, baby?
Yes, I
Okay, then let's make a little bit neutralization reaction. Neutralization means what? For neutralization purposes, we have sodium hydroxide as base. Then we have hydrochloric acid formed to acid. Then what we have just cross coupling between what? Between the ions of solutions. Let me write this one in blue, hydroxide and sodium, then the other ones in red, since they are acid. Then we have what? We have double displacement, interaction between plus of first one and minus of second one, which will yield sodium chloride, and also we have interaction between those two guys and we have water. Okay, this is the case. This is the first way to do such kind of neutralization reactions, but I want you to think about in that way. We have 2 liters of 0.1 molar hydrochloric acid, okay?
Okay.
Then I want to add 4 grams of sodium hydroxide in it.
Okay.
What will be the resulting pH for this reacted mixture? Very first, I want to find the number of moles of hydroxide and number of moles of hydrogen in this scenario.
Mhm.
The very firstly, I believe we may remember, we have 0.1 mole of sodium hydroxide, which will yield the mole of hydroxide also 1.1 mole. Okay?
Okay.
Then what happened for the aqueous solution? We have molarity and should be divided by volume. Then the molarity is something of 1 mole. We have no idea. The volume is 2 liters. Then we have the mole for hydrochloric acid is 0.2, 0.2 moles. Then we know that since we have only 1 hydrogen for hydrochloric acid, then we have the same amount of hydrogen present in the solution. Then we have what? We have the reaction between hydroxide and hydrogen, which will yield something like that. What we have? We have a little bit neutralization. Then we have some amount of leftover. How many moles of neutralization can we observe, baby? How many moles of neutralization can we observe from this scenario?
We have 0.3 of total.
No, baby. We have 0.1 mole of hydroxide and 0.2 mole of hydrogen. Since we have to connect those two ions to each other to yield water, and we have 0.2 for one and 0.1 for another, then we have only 0.1 mole of neutralization, no?
Yes.
Did you get the idea?
Yeah.
Because it's just something like that, baby. Maybe we may think about neutralization is something, let's say we have a pencil, then we have a cup. The cup is hydrogen plus ion, the pencil is the hydroxide. In our scenario, we have two cups, let's say, but we have only one pencil. How many pencil closed we may have? We just able to close only one, then we have left one more cap, baby. And after that, we may say that 0.1 mole of hydrogen will be left over. Okay?
Okay.
Okay, baby? Do you get the idea?
Yes.
Then we have what? Then we have, since our solution contains the hydrogen ion mole as 0.1, this will have some consequences. For example, the leftover hydrogen should have a concentration, which is the leftover mole should be divided by the volume of total solution. Then it will be again 5 times 10 to minus 2 molar, and again we will have pH of 1.3. Did you get the idea, baby?
Yes, I do.
This is the case. This is the case because we have a neutralization reaction. Very firstly, according to previous concentration, we have the pH of 1. No, because this one is something yield hydrogen ion concentration as 10 to minus 1 mole. Then it will be pH of 1. And after the reaction, we will end up with the pH of 1.3, which means our pH will little change through the neutral concentration, which is just because the neutralization reaction, because we consume up some amount of hydrogen ions to neutralize the added hydroxide ions. Okay?
Okay.
Then we have partial neutralization. Okay?
Okay.
This is partial neutralization. Then I want to ask you, how many grams of sodium hydroxide we should have for complete neutralization of 2 liters? No, let's make another volume, 5 liters, and with 0.2 moles. Okay, how many grams of, let's say that times we have potassium hydroxide. How many grams of potassium hydroxide is required to neutralize this acid solution, baby? Okay. Very firstly, we have to understand how many moles of hydrogen ion we have. And to do that, we have to face up with concentration equation, which is we have 0.2 molar of anything we have no knowledge about mole, but we have the volume of 5. Then we will have, okay, then we have 1 mole, no? 1. We have 1 mole of hydrochloric acid, and it will yield, since it only contains 1 hydrogen in it, then we may say that we have 1 mole of hydrogen plus, okay? And to neutralize them, we should have the mole of hydroxide also 1 mole, no? And 1 mole of hydroxide should be resulted from 1 mole of potassium hydroxide, and which is 39 plus 16 plus 1, which will be 56 grams of potassium hydroxide at 1 mole. Okay, baby? Did you get the idea?
Yeah, I did.
For the case of such kind of calculations, we have to really firstly find how many moles of what we have. For the solution of this one, we have 5 liters and 0.2 molar of hydrochloric acid, which is 1 mole actually, and it also contains 1 mole of hydroxide. And to neutralize them, we have to add 1 mole of hydroxide. Okay, baby?
Okay.
This is just a case. Let's check if we have sulfuric acid as acid, which let's say 0.2 molar and 3 liters. Okay? Then I want to ask you, how many liters of sodium hydroxide with 3 molar is required to neutralize sulfuric acid solution, baby? Okay?
Okay. We have
Let's
0.6
liters of solution. Okay. You said something really clever. We have what? Say again.
0.6 of the H2SO4.
Yeah, 0.6 of H2SO4, which yields hydrogen ion mole as what, baby?
1.2.
This is best. This is the best answer you ever said, baby. It will be the 1.2 moles of hydrogen plus we have. And in order to neutralize, we should have that much of mole of hydroxide. It should be 1.2 mole, and which should be resulted from sodium hydroxide, which contains 1:1 hydroxide ratio. Then we may say that we should have 1.2 moles of sodium hydroxide. And what will be the volume of neutralized solution? It will be easy.
0.4.
Yeah, this is perfect, baby. Since we have 3 of it, then 0.2 and the volume will be 0.4 liters, or in ml, it should be 400 ml, or cc and ml, centimeters are the same thing. Okay, baby. Okay, this is really good, baby. This is really good. Okay, I believe you get it quite well. Okay, this is really perfect. Then let's make one more example, which is reaction in acid, 5 liters of 0.1 molar of, let's say, nitric acid, which react with, let's say, 6 grams of magnesium metal. Okay? And I want to ask you, what will be the final pH for this solution after the reaction? This is quite interesting. I believe you get the idea we have the mole of acid as 0.5
5.
mole. I believe you get it, no?
Yeah.
Then we have some mole of magnesium, which is 6 should be divided by 24 and will be 0.25 moles. Why? Because the mole atomic mass of magnesium is 24. Then let's see what we have. We have a reaction between a reactive metal and a good acid. And our metal is something 2A. And it should be turned into magnesium plus 2 after the reaction. And we have what? We have hydrogen and nitrate ions. If one chemical species is changed its oxidation state from 0 to plus 2, another one should be just do the opposite way, which means it should be turned from the plus 1 to 0. And in that way, we should have hydrogen gas produced, and we have the coupling between magnesium and nitrates. And will be something like that. We have 2 of nitrates we required. Then we need to check whether we have balanced chemical equation. I believe no, since we have 2 hydrogen produced and we need to find 2 nitrates. I believe we should have 2 for the coefficient for acid, nitric acid, okay? And then our reaction will be bad. Our reaction will be something like that. 1 mole of magnesium should react with 2 moles of acid. Then we have what? We have 0.25 moles of magnesium. And how many moles of acid we require? The required mole of acid will be 0.5. And by chance, but this is really literally chance, baby, we just have that mole of acid, which will result in pH of 7 after the reaction. Okay, but this is just by chance. This is just by chance, okay? Okay, let's make these numbers a little different. I mean, let's say something like that, baby. I want to say that we have pH of 1 with 10 liters of hydrochloric acid, which will react with 2.3 grams of sodium metal. And what will be the final pH after the reaction, baby? Okay? Okay, then let's see. We have the hydroxide ion concentration as 10 to minus 1 molar. And we have the volume of 5 liters. Then from the equation of this one, we have 10 to minus 1 and divided 5. Then we say that as a mole of hydrogen plus, we have 0.5 moles. No? We have such kind of thing. Then let's see what we have as metal. We have 1 mole of sodium is something 23 grams. Since we have 2.3, then we will have 4.1 mole of sodium. Then we need an equation, which is the reaction of sodium with hydrochloric acid, which will yield sodium chloride and hydrogen ion. Hydrogen, not ion, hydrogen gas. How I figure out this one? Since sodium is an active metal, It's alkali metal indeed, and it should have the oxidation state of +1 after the reaction. And we have hydrogen plus and Cl minus in the solution. And by redox way, this hydrogen plus should be turned into 0, and other two guys should be interact to yield a sodium chloride salt. Then let's check what we have. We should have 2 for this one. Okay, then we will end up with this and also this, which means we have to add as 2 coefficient for almost all chemical species in the reaction except hydrogen. Okay, baby. Baby, are you good?
No, I'm here.
Okay, then let's check. Let's check what we have. We have the mole of 0.1 for sodium. Then we have mole of 0.5 for acid. Let's make this one as ice, baby. Let's make this one as ice. I believe we have limiting reagents as sodium. Then that much of acid should be used up, and that much of sodium chloride should be produced, and also 0.05 moles of hydrogen gas should be produced. And after that, we have no hydrogen, sorry, no sodium. Then we have 0.4 moles of hydrogen and 0.1 and 0.05 of hydrogen. Okay, David?
Okay.
But this hydrogen is hydrogen gas, and this one is something ion. Okay?
Okay.
Indeed, especially this one is not hydrogen plus, this is acid, but as a definition of acid, acid is some chemical that produce hydrogen plus ion in its solution. Well, let's check, because we have to find the pH of resulting solution after the reaction, baby. Let's keep the pH of starting solution, which is 1. Then let's try to find the final pH for this solution. The molarity should be calculated in that way. I believe this one 5 liters, no? I believe this one 5 liters. We have 0.4 mole of hydrogen and should be divided by 5, and it will be yield as 0.08. What? Is it true, baby?
Yes.
And then to get pH, we have to take the minus logarithm of 0.08, which will result as what?
Minus 0.0008.
I don't think so, baby, because we still have minus for this one. We just need to find the value of logarithm of 0.08. What it will be, baby?
Okay, sorry. It's 1.09. I mean, with the minus.
0.09. Okay, then because this minus will turn into plus after the operation, then we have the pH of 1.09, which we may say that since we add a little amount of metal and we just neutralize almost 20% of acid, the pH is not changed dramatically. Okay? Let's keep this phenomena in your mind, because normally the pH of acids or bases generally want to stay constant for a while, then suddenly they change around neutralization pH, baby. Okay? It will have such kind of S-shaped graphs they have. Normally, they try to keep their pH value constant for some amount of neutralization, then the pH will be changed really suddenly, baby. And after that, even with 1 or 2 drops, the pH changed from an acidic region to basic region really suddenly, very sharply. Okay, please keep your mind, and we may say that the neutralization graph should have such kind of S-shaped graphs, baby. Okay?
Okay.
And those graphs will be the subject of our next lesson, which is what? Which is Monday.
Monday.
Okay then. Okay, baby, do you have any questions? Because I have run out of lectures. Out of words to say.
No, I think I got it perfect.
Okay, baby, I believe you get this one also really good. And this is the really maybe the hardest topics for AP classes, baby.
Enthalpy was much harder for me.
Which one, baby?
Enthalpy.
No, you will see that when we start to solve questions, you will see that the enthalpy is really one of the good ones. Not easy, the good ones.
Okay.
Enthalpy is a good one, baby. The bad one is equilibrium. The ugly one is atomic structure. The bad and ugly, baby. Okay then. See you, baby.
See you. Bye.
Okay, bye-bye.